Hello everyone, welcome to the Voice over IP lab session. Hope you can remember the theory that we have discussed on the Voice over IP. So in today's lab session, I'm going to show you how to configure Voice over IP services in your networks using Packet Tracer. Now I have given this basic Packet Tracer file in your concept, so I want you to open it up and configure in the same diagram which I have provided. Couple of things that I need to highlight. If you are doing this from the scratch, from the beginning, you can't use any router for this. Note that I have labeled my routers as 2811. So if you are using a router to enable voice over IP, you need to get a router which is supporting the telephony service module. So this module is supported by several of the routers in Packet Tracer. Now note that I am using the older version of Packet Tracer, which is 6.3. If you're using a newer version, you get many models here which supports telephony service by default. So the one that I have selected is 2811 router right here. So if you're doing this from the beginning, or if you're doing this for online, make sure all the routers that you're using in your network which need to have voice over IP are 2811 routers. Okay, let's go ahead and configure. Now you can see in the diagram I have two routers here, R1 and R2, and I have a couple of switches connected to each router, and I have a couple of PCs connected to the switches. Now you can see I have given you a couple of IP blocks. The WAN between router 1 and router 2, which uses 22.22.22.0/30 networks. Since this is a 30 network, you know that this block can give us only 4 IP addresses. Out of those 4, only 2 are usable because the first one is the network address and the last one is the broadcast address. So in that case, the 2 usable IPs that we can use are 22.22.22.1 and 22.22.22.2. So I will assign 22.1 here, 22.2 right here. Additionally, I have given you 2 VLAN 100 and VLAN 20. So in this switch, we need to have 2 VLANs. VLAN 100 is for the data, that means is for the laptop 1 and the PC 1. I have created another VLAN 200 for the voice, which means we are going to use a couple of phones, and let's see how we can configure. So for that I have given you VLAN 200, which is known as the voice, and I have given you blocks. For the data, we are going to use 192.168.122.0/24, which means we can use any host from 192.168.122.1 to 254. And voice, I have given you 202.200.2.0/29, which means this block is from 202.200.2.1 to 202.200.2.6. Altogether we have 8 addresses, 6 are usable. And for this side also I have done the same thing. For the voice, we have 144.144.128/25, and for the data we have 199.99.99.0/24. So I told you in the lecture, if you can remember in voice over IP, that it basically provides an opportunity for an organization to use their existing local area network or their existing network to make voice communications. So what we have here is a kind of a network which is existing in a certain organization. Let's assume that this is our network, and you can see currently we don't have any phones, so we are going to use this particular LAN, which is a LAN that we already have, and we are going to enable voice communication. Now there are 2 ways of doing this. Like I explained in the lecture, there are 2 types of phones available. If you are using voice over IP, which means you are using IP protocol, which means you need to have IP address. So you can buy a special phone which looks like the traditional phone, nothing different. Only difference is these phones, they have an IP address. So these phones are known as IP phones. So you can buy something called an IP phone. Make no mistake, it's exactly similar to a traditional phone with a receiver. Only difference is, now a traditional phone will have RJ11 port, which is also known as the phone cable connector, and it has only that particular port. maybe you have seen this. If you have a landline connection, a telephone in your home, the cable, the port which is connecting that cable to your phone is the RJ11 cable, and the port, which is basically like a smaller version of the RJ45 Ethernet port. Now the difference in a normal traditional phone and IP phone is that IP phone has a normal RJ45 port. That means just like your PC, it has a Ethernet port, and also IP phone can have an IP address, which means it basically doesn't need a converter like a modem to convert this analog signal into digital signal. Instead, the phone itself is working with digital. That means it can have an IP address. So for the right side of this network, which means for the R2 network, I'm going to use IP phones. So we can go to end devices, and you can see the IP phone, which is 7960 model, is available right here. So I'm going to add two IP phones, IP phone 0 and IP phone 1. To identify in the packet tracer, you can see you're getting a phone icon and you have this IP sign right here. Now to connect these to a switch, just like you're connecting a laptop or a PC, you need to get a copper straight through cable. Let me connect this to the switch side, fast Ethernet, let's say 5/1 to the IP phone 0, and in this way I have two ports actually in the IP phone side. I have the switch port and the PC port. Since I'm connecting to the switch, I'm going to select switch right here, and let me do the same thing for the IP phone 1. I'm going to connect this to 6/1 of the fast Ethernet of the switch and to the switch port of the IP phone. So note that I have two phones connected, 5/1 and 6/1. Now let me assign a couple of numbers. Now you know phones doesn't, even though they can have an IP address, we can't dial an IP address, right? We need to have an extension number. So for this phone, I'm going to use the extension number 1111, and for this one I'm going to use the extension number 2222. Now make sure in your diagrams also you are connecting like this. After you do this, we can go ahead and configure. Now there are a couple of things that we need to pay our attention on. One thing, if you go to a PC, the PC will have certain options for you to assign IP address. Now we have done this in the labs. You can basically go to the static configuration and assign IP address. But if you go to the phone, there's nothing called IP configuration, and at the moment we have not powered on the device as well. So we can't manually go ahead and assign an IP address for an IP phone. So we need to find a way in order for us to communicate with these phones how to assign an IP address. Now I'm going to give you two methods. Even for the PCs today, I'm not going to assign an IP address manually. Now imagine this. Imagine this switch has a couple of other switches connected, and you have like thousands of PCs that you need to give the IP connection to. Now if you are the network administrator, it will be very difficult for you, because you have to manually go to each PC and assign the IP address. But we usually never do that. So what you do is, we use a service called DHCP. We use a protocol called DHCP. Now DHCP stands for Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. So let me show you how to configure a DHCP service in the router. So a router will automatically assign these IP addresses to the phones and for the PCs. So I'm going to start with the VLAN configuration. Let's go to the switch 1, a CLI. Let's configure the our VLAN. So we have two VLANs. I'm going to go to the configure terminal. Since it might be difficult for you to see this, I'm going to increase the font size a little bit so that you can see this clearly if you're running this on a low resolution or raw resolution when you're playing this. Now let me increase the font size to maybe 14, so you might be able to see this clearly. I hope this is clear now. So I'm going to go with creating of the VLANs. Now the first VLAN I need is VLAN 100, and the name of it should be data. And let me create the second VLAN, which is VLAN 200, and the name of it is given as voice. Now please note that the data VLAN is for the PC 1 and laptop 1, voice VLAN for these two IP phones, IP phone 0 and IP phone 1. Now when I create these two VLANs, I need to make sure that I configure all the ports correctly. If you can notice, this fast Ethernet 0/1 of switch 1, which is connected to the R2, should be a trunk port because it has multiple VLANs, multiple VLAN data taken to the router. So I'm going to go to interface fast Ethernet 0/1, and I'm going to make sure this is a trunk port. So I can issue the command switch port mode trunk. So fast Ethernet 0/1 will become a trunk port. And let's assign the PCs to the correct port. So I'm going to go to interface fast Ethernet 2/1, which is connected to laptop 1 right here. I'm going to switch port access. It should access VLAN 100 because laptop 1 should access VLAN 100 data. And similar way, I can use interface fast Ethernet 1/1. It should also access VLAN 100 because 1/1 is connected to PC 01. So I'm gonna assign my phones to the correct VLANs also. So you can see fast Ethernet 5/1 right here, which is IP phone 0, should be in VLAN 200, and fast Ethernet 6/1 should be in VLAN 200. So let me do that very quickly. Let me go to the switch again. So we can say interface. I can assign these two ports together using the range command, but I'm not going to do that for the sake of the clarity of the lesson. So I'm going to assign them separately. Interface fast Ethernet 5/1. Now the usual command that we use to assign a VLAN, a port to a VLAN, is switch port access and the VLAN number. But this is a voice VLAN. Because of that, I'm going to use the command switch port voice VLAN and the VLAN number. So it should be switch port voice VLAN 200. And also I'm going to do the same thing for the other port. That means interface fast Ethernet 6/1 should be switch port voice VLAN 20. So the command voice indicates that these two should access the voice VLAN. Now we have assigned all the ports to the correct VLANs and we have configured the trunk ports. So let's go ahead and configure the router, because if we have two VLANs, you know that there should be two sub interfaces in the fast Ethernet 00, because this will be our default gateway. Now since I have given you two blocks for the VLAN 100 and 200, I'm going to use the last usable of each block into default gateways. And you know, for the VLAN 100, 192.168.122.0 has been given, so the last usable will be 192.168.122.254. For the VLAN 200, 202.200.2.0 has been given /29 as the block, so the last usable will be 202.200.2.6. So I'm going to use them in my sub interfaces. You can see the main interface is fast Ethernet 00. So let me go to the global configuration mod, and the interface is interface fast Ethernet 0/0, but the first sub interface I need for the 100, so I'm going to say .100, and I'm going to use encapsulation .1q100, and let's assign the IP address. So for the 100, the given block is 192.168.122.254 because I'm using the last usable, and the subnet mask will be 255.255.255.0 because it's a 24 network. And let me create the sub interface 200 as well. So interface fast Ethernet 00/200, and we can say encapsulation should be used with IEEE 802.1q with the port 200, and I'm going to use the IP address. So the last usable of IP address for the voice VLAN is 202.200.2.6, and it's 255.255.255. It's a 29 network, so it becomes 248. And we need to make sure the fast Ethernet 00 port should be turned on. So I'm going to exit from it, and I'm going to say interface fast Ethernet 0/0, the main interface. I'm going to issue the command no shutdown. So this command will make sure that all of these ports sub interfaces are turned on. Now if I go to my diagram again, you can see these ports are turning on, and fast Ethernet 01 is already a trunk port, so there's no problem with the communication. Now usually at this point what we do is we assign the IPs to the PCs manually. That means if we are assigning for the laptop we can assign something like 192.168.122.1, and for the PC we can assign 192.168.122.2. but we are not going to do that. Like I said earlier, we are going to ask the router to do a DHCP service to assign the IPs automatically, and for these phones also. So let's go to the router again. Let's configure this DHCP service. I'm going to go to the global configuration mode, and I'm going to issue the command IP DHCP. This is a command to enable dynamic host configuration protocol in your routers. And I'm creating an IP pool, which means I'm going to give a range of IPs for my router to use when it assigns the IP to the PCs. For example, if you think about it, for the data VLAN, if any PC is connected to the data VLAN, I'm going to say to the router, router can use any IP between 192.168.122.1 to 192.168.122.254. So the router knows that any PC belong to the data VLAN will get one of those IPs in that range. However, we have a small issue. 192.168.122.254, the last usable is already given to the default gateway. So we have to additionally say to the router, okay, the range you can use for the VLAN 100 is 192.168.122.0, sorry, 192.168.122.1 to 192.168.122.254. However, the 254 shouldn't be used because already in use. So that is exactly what we are going to use. Now you can understand, we are giving a range. Now this range is known in networking as a pool. It's a pool of IP. So I'm going to say pool, and I can give a pool name. Let's call it as data IP pool. So we know that I'm referring to the IP pool for the data, and you can see the prompt is changing from config to DHCP configurations. So let me assign couple of parameters. So first of all, I have to say that in this pool, what's the range? So I can say network is 192.168.122.0. the subnet mask is 255.255.255.0. Now when I issue this command, router automatically figure out the range, because it knows that if the network address is 192.168.122.0 and if the subnet mask is 255.255.255.0, it knows the usable range will be from 1 to 254. Now additionally, we have to say what is the default gateway, because when we are assigning IPs to the PCs, we have to assign the default gateway. So to do that, I can say default router is 192.168.122.254. that's the default router. Now let me exit from the DHCP configuration, and I have to instruct that 254, that means the default router's IP address should be excluded. That means it shouldn't be used. So I can say IP DHCP excluded address. I can say okay, 192.168.122.254 should not be used. So now my IP DHCP configurations are complete for the data, but for the voice we have to complete it. We will do that in a moment, but let's go through the command very quickly. So I have created a data pool or IP pool named as data IP pool, which contains the IP address from 192.168.122.1 to 254, and I said that 254 is the default gateway, and I also said that for the host do not use the 254. So let's see whether this is working or not. So if we go to laptop now, if we go to the desktop IP configuration, now we are in the static mode, but if we click on the DHCP, see we have option called dynamic host configuration protocol, then this PC should request an IP from the DHCP server, and the DHCP server that we have configured, the service that we have configured in the router, should assign IP address automatically. Let's see whether it works or not. So if I switch to DHCP, you can say it's requesting for an IP address and successful, and the IP address has been assigned. And if you look very carefully, you can see the IP address that was given to this particular laptop is 192.168.122.1, the first usable, and the subnet mask is correctly assigned, and also the default gateway has been assigned. So this is the easy configuration of the DHCP, easiness of using DHCP. If you have 100 PCs, you can simply do that. So let's go to the PC 1, desktop IP configuration, just click on DHCP. That's requesting an IP, and you got it, because now you're getting 192.168.122.2, the second usable IP. So likewise, if you have 100 PCs, the DHCP server running here will assign IPs automatically. So it's very easy for you to use it. Now all we have to do is configure the DHCP service for the voice, because we haven't created for the voice, we only create for the data. So let's go to the router and do the same thing. So I'm going to say IP DHCP. I'm going to create a different pool for this one. I'm going to name it as voice IP pool. Okay, and the network, now network for this one is 202.200.2.0, and the subnet mask will be 255.255.255.248 because it's a 29 network. And also we can say default router. So default router or the default gateway is the last usable of this block, which is 202.200.2.6, which we have assigned. So that's a default router, and we can use option 150. Now you're wondering what is option 150. Now the difference between these two is that we have something called data. This is for the data, so you don't have to instruct to the router saying that we are assigning it to different type of hosts, because anyway it's just basic laptops and PCs. But the voice is different. Voice data should not be considered as same as the voice data. So we have to say to the DHCP server that we are specifically assigned this to telephones, IP phones. The way to do that is by setting an option. So we have option 150. So this option 150 is basically giving us the chance to assign or instruct to the DHCP server, saying that we are going to assign, or the router is going to be assigning this to IP phones, not for the host. So it's in a way it's easy for you to differentiate between data voice pools and voice DHCP pools. Now always remember, if you are doing this, you need to set this option, otherwise the router will not recognize that this is assigned to a telephone network. So you can say option 150 IP 202.200.2.6. now that is also configured. That's all that you need for the voice data. However, we need to make sure that 202.200.2.6 should be excluded. So I'm going to say IP DHCP excluded address should be 202.200.2.6. that means we're instructing to the router saying that this particular IP 202.200.2.6 should not be assigned to any of the phones. So that is also done. Now before I turn on the power of these IP phones, I am going to configure the telephony service, the voice over IP service. If you can remember in the network lecture or the voice over IP lecture, I mentioned that another name for the voice over IP service is known as telephony service. So telephony service is a special service that you're getting, or other special module that you're getting with these 2811 routers for you to configure voice over IP services. So before I power this on, I'm going to go to my router and configure my telephony service network. Now let's go to the privilege mode and then global configuration mode, and let's issue the command. So I'm going to issue the command telephony service. So telephony service is the command to enable IP4 service configuration. So you can see your prompt is changing from config to config telephony. Now we have to define how many phones that we need, and for each phone how many directory numbers. Directory numbers means the line numbers that we are going to assign here. So if you look at the network, we need to have 2 directory numbers and 2 ePhones. So let's do that here. I can say maximum ePhones. Max ePhones are 2, and maximum directory numbers, maximum DNs, direct numbers should be 2 as well. So we need 2 ePhones, 2 directory numbers. Additionally, I have to say what should be used as a source address. That means what is the router's gateway address. One more thing, if you are communicating voice over your local area network, you need to specifically assign a unique port number to handle that data. So you're configuring a unique port number to handle the data. For example, if you're using web data, you know the port number is 80. If you're using email data, that's 25. If you're using telnet data, that's 69. So likewise, since you're handling voice data here, you need to allocate a dedicated port number. You can configure any port number. For this particular example, I'm going to use port number, let's say 2000, but you can use any custom port number. You can't use 80, remember, because that's been already used for the web data. Now assign a custom port number which is pre in your network, and you can configure it to handle all the voice. So I'm going to say IP source address, and the source address is 202.200.2.6 because that's the router's gateway address, and I'm going to say use the port 2000 for this one. So this is a way of instructing to the router, saying that okay, the voice data should be sent to port 2000 on this particular IP. Now we have configured our telephony service. Okay, sorry about it, I forgot one more command, so I'm going to go back to the telephony service. So what we did was we set the maximum ePhones to 2, maximum directory numbers to 2, and we set the IP source address should be 202.200.2.6 and port 2000. And we have to say, when you assign the line numbers, automatically configure them. Now we can do it manually as well, but it's not in your syllabus, so we are going to look at how to automatically assign the line numbers. So I'm going to say auto assign from which phone to which phone, from which DN to which DN. So we have only 2 phones, so I'm going to say assign from 1 to 2. Now remember, if you have 4 phones, then it should be 1 to 4. If you have 10 phones, it should be 1 to 10. Let's say you have 10 phones to be configured, but you want to automatically assign only from 5 to 10, so the number should be auto assign 5 to 10. So hopefully you understand what these numbers mean. Since I have only 2 iPhones, IP phone, I am going to select 1 to 2. Okay, now before I assign my line numbers, I'm going to turn on, I'm going to give power to my ePhones. Now let me power on the first one. So IP phone 0, and you can see in the physical view you have this power cable. This is a power cable adapter which you can drag and drop very carefully into the plug right here. So let me zoom it and show you. So this is what we have. So this is the power port. So drag and drop this cable to right here, which should basically connect and turn on the power. And you can see this is turning on. Now let me show you a small trick. Now you can do this without waiting, but believe me, it will be easier for you to keep a track of what's going on in this way. Once I turn on the power, I'm going to wait until this port becomes green color, which means the port is listening at the moment and will learn in a moment, and then to go to forwarding state. So I'm going to wait until this IP phone is communicating with the switch in the forwarding state. Look at it. Now after 30 seconds it became green color. Not that I'm not going to turn on this one. Reason for it. Now I'm going to say to the router, assign the line number 111. Now since I have automatic configuration, if I turn on both phones at the same time, router can assign randomly. So I don't have a control over which phone will get 1111. But in this case, since this is the only phone which is turned on, router will definitely assign number 1111 to this one, and later we will turn it on and assign the second one. Okay, so I'm going to go to the router and I'm going to say ePhone DN1. So ePhone DN1 means our phone number 1. You do that, you can see when you do that you get a kind of a message. Press enter and you are in config ePhone DN. So I'm going to say number, so the line number 1, now 1, now 1, now 1, now 1111. Now when you press enter, I got the message saying that the phone 1 on 202.200.2.1 on circuit 2 has registered. Now you have to wait until you get the message. Now I got it immediately, but in some cases if the switch is still configuring, if the router is still encapsulating, it might take up to 2 minutes. So you have to wait and see until you get this message. Now if you get this message, you can go to your phone and hold the mouse pointer on top of it. You can see it has an IP address automatically assigned, which is 201.200.2.1, and the line number 1111 has been assigned. And if you click on it, if you go to the GUI, you can see the phone and the line number 1111 is displayed right here. Okay, let's go ahead and assign the second one. So I'm going to go to the second phone and drag and drop that power cable to turn it on, and I'm going to wait until this becomes green color. So note that like you have learned in the previous subjects, a switch port can be in either listening mode, learning mode, forwarding mode or blocking mode. Usually at the default configuration, a switch port spend around 15 seconds on listening, 15 seconds on learning, and then it will either go to the forwarding state if everything is okay. If there's a problem, it will go to the blocking state. Now at the moment it's listening and learning, and if everything is okay, it will go to the forwarding state like this. Okay, now it's in the forwarding state, and let's go to the router. Let's exit to the global configuration mode. So I'm going to configure ephone DN2, and I'm going to say number for this one is 2222. Now I'm waiting till I get the message registered. Now last time I got it immediately, but this time it looks like it's taking some time. So let's wait and see how long does it take. If your configuration is correct, it should come within 2 minutes. If it is okay, now I got the message registered, and you can see it's 202.200.2.2 has been assigned, and we have IP phone 1 connectivity, and in the GUI we have this as well. So let me show you the best part. Now you will be able to make a call from one phone to another phone. Let me show you how it happens. So I'm going to go to one of these phones, and I'm going to click on the other phone as well. I can make sure both are visible like this. So both phones are visible, and you can see one has a line number 1111, the other one has the line number 2222. So I'm going to dial 2222 here. If you want to hear the dial tones, the sounds, you can go to options, preferences, and turn on play telephony sound option. You can turn this on, play telephony sound. Now let's go back to our two phones. So I'm going to open up this one and the other one as well. I'm going to see both are visible. So I'm going to dial the number. So I'm going to dial 2222 here. So 2. Okay, now I have dialed the number, and I'm gonna make a call. To make the call, I have to click on this red color line here to lift off the receiver. So if I do that, now you can see you are getting a call from 1111, and you can hang the call by keeping the receiver. And also you can make a call from this phone to the phone as well. So this phone's line number is 2222. If I want 1111, and you can see the phone is ringing. Okay, so this is an example of how we can configure voice over IP. Now this is the first part of this lesson. I want you to configure this, and see you in a bit in the second part on configuring the other side and the voice routing, which is the most important part of this particular lesson.